Hi students, welcome to 9th class online classes. Congratulations all of you. You reached your 9th class today. I am going to teach you the physical sciences first lesson, that is motion. So it will be in two parts or three parts. Okay, the first part today I will teach you. So motion is a part of a physics. In the physics, there are kinematics and dynamics. Kinematic and dynamics, you can observe the motion. In kinematics, if there is no reference to the force, then the body under motion, then we say they are under kinematics. So in the motion, first we learn rest and motion. If you observe the tree is not changing its position. Okay, so the tree is under rest. If you observe tomorrow also, the tree will be there only, and it is under rest. But if you observe the monkey which changes its position continuously, then we say the monkey is under motion. Okay, let us in depth we'll learn. Okay, rest, as I said, it is the position does not changes with the time, and motion, position changes with time. The position of the object with respect to time changes continuously, then the object is under.
Can you identify the objects you see on the screen? Birds, fish, butterfly, house, factory, seesaw, clock, train, etc. Classify these objects as moving bodies and objects at rest, respectively. The classification is shown on the table. How did we classify as objects at rest and in motion? If the position of the object changes with time, it is classified as objects in motion. Whereas, if the position does not change, it is classified as objects at rest.
Understood? Okay, we'll go to the same another case. Okay, if you observe the diagrams there, one boy is moving from left to right and observing the tree. Another boy is moving from right to left and observing the tree. The boy who goes from left to right, he says the tree is on his left side. And the boy who is moving from right to left, he says the tree is on the right side. So where is the difference? It is a relative to the observer. So motion is always a relative to the observer. So object being observed and the observer, it is a combined property. So motion is a combined property of the observer and object being observed. We will take another case. Okay, a person who is moving from right to left, and another boy who is sitting in a car and moving from right to left. Okay, a boy along with his pet is sitting in a car. You have learned in the 7th class that for boy and the pet, both of them are at rest inside the car. Along with the car, they are moving. For example, when you take the earth, motion of the earth. Okay, earth is rotating. Can you identify? Can you know? No, because you are not relative. Okay, you are not observing anything. If you observe the stars, then we say earth is rotating. Okay, so here a boy is moving from right to left. Okay, the same a car is moving from right to left. But what the person feels who is sitting in the car, he will feel that tree is moving behind him. But actually, who is moving there? The car is moving. And if you observe a many person who is standing stationary, then they feel the tree is at rest. Okay, so it is a combined property of the observer and the object being observed. Then we learn about the distance and displacements. If you observe the diagram there, it's a big mountain. Okay, one wants to travel from one side of the rocky mountain to the another side. Okay, he chooses a path which is in the red color and reaches the other side. Okay, if you can able to cut the rocks and reaches the same point, then the green color path will give you the displacement. Then what is the distance? So distance is the length of the path traversed by a body in a given time. Okay, it is a path traversed in a given time. Okay, whatever the curves may be, total length, if you consider, it is called as the distance. Okay, if there is a direction in one specified direction, how can you represent the quantities which are having directions? We can represent in vector. Okay, as a line segmented arrow. Okay, then line segmented arrow are directed with a line segmented arrow, then those are called the vectors. The magnitude, the length of the arrow will indicate the magnitude, and the arrowhead indicates the direction. So we can represent this vector quantities having both direction and magnitude. Okay, so displacement is a vector because in a specified direction. Okay, then what is displacement? It is the shortest distance covered by an object in a specified direction. If you observe a car which is moving in two different paths, one A S B, another one A to B. Okay, if you draw a tangent there, then the tangent will indicate the speed. We will learn later. Okay, now ASB is a path traveled by one car and AB is a path traveled by another car. Okay, so the length of the path traveled by the object is given time is the distance. You have learned already, isn't it? So it is a time dependent quantity, and AB is displacement. Okay, and ASB is the distance. Okay, AB is the shortest path, so it is displacement, and ASB is the distance. If you take two figures or diagrams, okay, in first figure A to B, okay, a person traveling in the east direction and takes towards north in the middle and reaches a point B. Okay, another one, A travels in curved path and reaches a point B. A is the initial point, B is the final point. Okay, if you draw a line connecting the B to A with an arrow, okay, then that line represents the displacement. Okay, or else here also if you draw connecting the A to B, okay, with an arrow line, okay, that indicates the displacement. Okay, so what is it? Actually, the shortest distance covered in a specified direction is called displacement. It is also a time dependent quantity. Okay, then AB is the displacements. If you draw a line connecting the initial point and final point, then that AB represents the displacement vector. So if I ask you, can you draw the displacement vector, it is very simple, connecting the initial point and final point. Now we'll try to learn the average speed and average velocity. If a person traveling in a car or a bicycle for some kilometers, okay, initially they started with 0 and reached 20 kilometers with a bike. First time, if he takes for 20 kilometers, he takes 20 minutes. Second time, because of the traffic, he takes 60 minutes. Then the total distance by total time will give you the average speed. Okay, let us observe with a motion. So here a car traveling from 0 to 10 kilometers with one speed and 10 to 30 kilometers with another speed. But what is the total distance traveled? 30 kilometers. And if you can add those two timings, the total time, then we can calculate the average speed. So total distance by time taken will give you the average speed. So it can be measured. For example, a train starts at Vishakhapatnam. Let us take Godavari Express. Started at Vishakhapatnam, reached the Hyderabad. Okay, it took 12 hours and it stopped at various stages and picked its speed several times and again stops at the stations. Okay, so how to calculate the average speed? So total distance by total time taken will give you the average speed. Okay, then at any place, okay, if it takes less time, okay, then it is traveling with the greatest average speed. Okay, then what is the average velocity? If you have to consider the direction, so starting point and initial point and final point, if you join together, then the displacement with respect to the total time taken will give you the average velocity. Here also it takes less time and more distance is covered or more displacement, then its velocity is more. Okay, you are going with a bike. Okay, if you observe the speedometer, what that actually gives, the speedometer gives the average speed at that point or the instantaneous speed, and we call them as instantaneous speed at that instant. Okay, it can be measured or it can be shown with a graph. Okay, if you draw a distance time graph, it can be shown. So we will observe this distance time graph. Distance, if you are able to draw on the y-axis and time on the x-axis. Let us say S1, S2, S3 on the y-axis, T1, T2, T3 on the x-axis, time axis. Okay, if you observe there, at the time T1, it reached a distance S1. At time T3, it reached a distance S3, and time 2, it reached a distance S2. Okay, if you want to take the distance traveled from S1 to S2 and average speed in between S1 and S2, then S2 minus S1 by T2 minus T1 will give you the average speed. Then how can you know the instantaneous speed? If you draw a tangent at any point, that will give you the instantaneous speed. If you observe another graph, as time and distance graph, okay, if you see at a point A, okay, distance traveled is more. Okay, if you draw the perpendiculars at this point towards x-axis and towards y-axis, then the point, if you observe, is for A it took very less time, and for B it took more time. Okay, for A more distance is traveled in less time, and B, less distance is traveled in more time. So easily we can say A is traveling with a greater speed and B is traveling with a less speed. So speed at any instance is called instantaneous speed. Very good. So average speed formula is S2 minus S1 by T2 minus T1. Then the slope. What is the slope? The tangent drawn at that point will give you the slope. If the slope is more, then it is going with a larger speed. Okay. Then can you draw the direction of velocity at that point? You can draw very easily if you take a curve. Okay, a path which is in a curved path. Then if you draw a tangent at any point you want, then if you draw a tangent, then it gives the direction of velocity. That what is a tangent? You might have learned in the maths. Okay, if you draw a perpendicular at that point, that will give you the tangent. Okay, so tangent drawn at that curve will give you the direction of velocity. Already you have observed this graph, isn't it? So A is traveling with a greater speed and B is traveling with a less speed. We will take one more example of the time distance time graphs. Okay, which values are drawn on the x-axis? Normally time. Okay, which is independent quantity, we'll have to draw it on the x-axis, that is time axis. Okay, and which is variable, the variable should be drawn on the y-axis. You have learned in the maths, isn't it? So the distance on the y-axis and time on the x-axis. We'll observe one example. Okay, if you observe an object, its position is 1.5 and at a time of 0.1 and also 0.2 seconds also it is in the same position. That means it is not changing its position. That means the body is at rest. Very good. Okay, then if you observe another case, okay, at 0.1 the object changes and 0.1 it changes to 0.4 and 0.2 seconds it changes to 0.8. Okay, there is a regular change in the position of the object. That line will give you the speed. So 0 to 0.8 seconds, 8 seconds or 0.8 meters, that line will show it changes its position. Okay, it indicates the speed. If you observe another one, okay, it's not changing its position, but the time is changing from 0.2 to 0.4, then what we say, the object is at rest. So we'll compare now the speed and velocities. Already the speed is the distance traveled per unit time. As it is not having any direction, it is a scalar, and the formula is distance by time. And what are the units? The distance units are meters, time units are seconds, so the units are meters per second. How can you represent any quantity? You should represent with a letter. Okay, you can represent the speed with a letter V, capital V, and it cannot be a negative. So displacement per unit time is called velocity, and because it is having a both direction and velocity, it is a vector quantity. So what is the formula? Displacement by time. And what are the units? It is the units are the same as the speed, that is meters per second, and it is also represented by the same letter, that is V. And speed in a specified direction is called velocity. Okay, so velocity can be negative and velocity can be 0. See, can the displacement be 0? Yes. How means if you take the hands in a clock. Okay, so the hands in a clock reaches the same position, okay, after 1 minute or 12 hours, isn't it? So here the displacement is 0. As the displacement per unit time is velocity, so displacement is 0, so velocity can also be 0. And as the direction changes, if a car going backwards, but it is changing its movement, but it is going backwards, or applying the brakes, car is applying the brakes, then its velocity can be negative. So velocity can be negative or 0, but speed cannot be negative. You will see with a one beautiful.
Alright. Yeah. Yeah, you feel me? Yeah. Spend a moment and just take a look all around you. People's dogs and plants, everything it constantly moves. Even still objects like buildings or lamp in your room, they're still in motion because our planet's always moving. Speed's the distance an object moves in time, like the speedometer when your car drives. Meters per second is the answer, the standard for the measurement equation. Average speed equals distance over time and scalar. Magnitude no measure of direction instantaneous. Speed is the speed of an object at a specific moment in time, and it may speed up or slow measured in meters per second. Speed only scalar, it doesn't tell us which way we drive. Calculated by measured distance divided by time. Like if you drove to your grandma's house just to say hi, you take the meters divided by the full time to drive.
Speed equals distance over time. Speed equals distance over time. Speed equals distance over time. Distance over time. Speed equals distance over time. Speed equals distance over time.
Now velocities are fast moving with direction. Numerical value vector with two measurements. Like you're driving 10 meters per second going west. The direction and distance is called the displacement. Say if you were walking to class, your exact distance follows your path, but displacement's the shortest distance from the starting to the ending. Equation equals displacement over the time instantaneous. Velocity, speed, second in time, acceleration is a measure of how fast the velocity of an object changes. It's also vector, use its size and direction. Let's say you walk to the store, it takes you 30 seconds. Walking west 100 meters, it is the full distance, but the displacement, it only shows 50 meters, so it's your velocity is 1.7 meters per second west.
Velocity equals displacement over time. Velocity equals displacement over time. Velocity equals displacement over time. Velocity equals displacement over time.
Enjoyed, children? Learned? Very good. Okay. Have a nice day. Thank you. Part 2 will continue.